Forward here, we have our Team 54 introductions. My name's CJ Campbell. We have Cam Johnson, Adrian Calderon, Max Chen, Aditya Prabhu, and not pictured here is Ryan Hay, who's currently sick at home. Our problem statement going forward here is so in current factory settings and warehouse settings, we want to ensure workers consistently use PPE, personal protective equipment, and it's usually a daily challenge for them. Current methods of PPE enforcement include manual checks or signage, which can lead to inconsistent monitoring. On a larger scale, many worker injuries can result from inadequate usage, and about 60% of workers use PPE during their usual workday. The main reasons for non-use are discomfort, lack of knowledge, and poor fit. Occupational incidents in the last 12 months were reported around 64.3%. And our team will be tasked with creating an intelligent vending machine system to combat this issue. Our scope of work here, our team's project this year involves creating an AI vending machine to dispense PPE for workers using a computer vision model. This model will be trained to detect the correct PPE when a worker approaches the work area. If the worker does not pass the detection process, they will have the option to dispense the PPE on site. Additionally, you have the option to create a safety gate or to create a framework for development of the safety gate later on. Some of the work methods we're going to be using is software architecture, computer vision / AI, so detecting that required PPE listed above, that's going to be mentioned. The embedded system development, which includes the GUI integration, the API communication development, and our optional part is the safety gate configuration.
All right, so I want to talk about review of the state of the art. So there were several pre-existing models and projects that are a vending machine to work automatically like ours, except they were all focused on medical equipment like surgical gloves and face masks and such. There was now pre-existing project or product of a model that was working with a safety gate that goes up or down, and none that worked for identifying factory PPE.
Yeah, so these are some of the design requirements for the vending machine. Really, you want your computer vision set up, your AI set up, and your core processing unit. So you need to have a computer vision system, a computer vision model that can actually detect the missing PPE, camera driver, a GUI interface that allows people to be able to interact with the vending machine and vend what necessary items they need. We need to have a safety gate logic controller to determine if the gate would open or close based off what PPE was detected at the dispensing logic that would correlate to the vending machine, the overall UI UX design for people to get introduced to the system, and just continuous model improvement of our computer vision model.
So looking at the first part of the solution being the computer vision model. So we're using YOLO V11 and transfer learning. So taking a larger pre-trained model and training it on our own custom data set to save time and effort on training the model. And what it does is it simply takes in an input image or frames from a video, runs YOLO V11 on it to detect the PPE, and then just shows it on the output as an annotated box on the outside. And the way that the model works now is that if the box has the label for the target PP, say, for example, for detecting helmets, if a box has a label helmet, it'll output a Boolean. So it would be helmet true. And if it doesn't, helmet false. And using this, we are detecting various PPE, such as safety glasses, helmets, gloves, and beard nets.
Next, we want to talk about where we're at with the project and the model right now. So we have a pre-trained model that we've used for initial testing. What we did was we tested 3, as you can see pictured here below, and model 1 did the best. So we're going to move forward with improving that model. Right now, we're waiting for the Jetson to be functioning properly so we can run and test it accordingly and improve its performance.
As for the graphical user interface part, we developed a GUI with the PyQt5. On the first picture, you can see the default state, and the second screenshot, you can see how the GUI will display the detected PPE, which will be the green buttons. And then pressing on any button will dispense the corresponding PPE. Some additional features of note is there's also an inventory management system seen by the table, as well as a report showing some graphs about the dispensed PPE. Now we have some demonstration videos. So here we have a demonstration for the graphical user interface of our project or a GUI. So first aspect is we're going to show that pressing on these PPE buttons will send a message to request the PPE to be dispensed. So if I press for hard hat, you can see here that the hard hat data has been sent. If I press gloves, the gloves data has been sent. Now, the next feature we're demonstrating is that these buttons show the status of the detected PPEs. And then here we can see that for our system, green buttons will show that these PPE has been detected by the computer vision algorithm. And then the red ones will be the undetected ones. And the idea is you want to press to dispense the PPE you're missing and then put it on for the computer to see. Now I'm going to demonstrate the gate. So, for example, if we have an emergency, we want to override the gate control over here. If you see it's lighting up red, which means the gate is locked. So we override it with your user role and then a specific reason. For example, in the emergency override, you can see that the gate controller turns green. The gate is now unlocked. And then after the specified override period, the gate will lock itself again.
Now we're going to play video 2. Video 2 involves testing. An example of testing the pre-trained model 1. Here you can see they're detected with a helmet and no vest, but an absence of safety glasses was not detected. Here, a helmet is labeled as a safety vest. Here shows the performance. Safety glasses are not detected, but everything else is. And that's the video, so you can see there's plenty of room for improvement. Here's our references. Thank you for your time.